Alright guys, welcome to the half-angle formulas. Okay, so what we're going to talk about today are three different formulas for sine, cosine, and tangent, and they are called half-angles. They are derived from the power-reducing formulas where you switch your theta and you switch that with alpha over 2. Alpha is an angle measure. So here are three equations. So sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 2. It's plus or minus depending on which quadrant you're in because the sign can either be positive or negative. Cosine alpha over 2 equals plus or minus the square root of 1 plus cosine alpha over 2. Okay, and tangent, you get three different choices. You have tangent of alpha over 2 equals plus or minus the root of 1 minus cosine alpha over 1 plus cosine alpha, and then you have tangent alpha over 2 can equal 1 minus cosine alpha over 2, and finally tangent alpha over 2 equals sine of alpha over 1 plus cosine alpha. And so what we're going to do today is we're going to apply these formulas to find different angle measures, or what we call half angles. So if the idea here is if you know maybe a full angle, you can figure out the exact value of the half angle. And just as a warning, I should tell you that the sine of alpha over 2 does not equal this. A lot of people get this confused, so make sure you pay attention to that big warning here. So let's get right into some examples. So when we talk about half angles, so let's say we find the exact value of cosine of 112.5 degrees. Now that is a half angle of something else. We don't know that exact value on the unit circle, but we can find it using these half angle formulas. So cosine of 112.5 degrees is equal to, well, what's half of 225? 112.5. So we're going to rewrite this as cosine alpha over 2. So our alpha is 225 degrees. So we are going to use the negative here because we're going to be in the second quadrant, and in the second quadrant cosine is less than 0. Cosine alpha is less than 0. Okay, so let's go ahead and substitute. Wherever you see alpha, okay, you're going to put that 225 degrees. So we have the cosine of 225 divided by 2 is equal to negative square root of 1 plus cosine of 225 divided by 2. Now, we know that cosine of 225 is going to be negative root 2 over 2. So we plug that in. Okay? So we have negative square root of 1 plus negative 1, or negative square root of 1 plus negative root 2 over 2, all divided by 2. What we're going to do now is we're going to multiply the radicand, that's the number underneath, by 2 over 2. And that's what I put here in green. The idea here is to get rid of that 2 here. Okay? So we get 2 minus root 2 all over 4, and we're taking the negative square root of that. Okay? So the square root of the numerator and the square root of the denominator, we can simplify this up, and you get negative root 2 minus root 2 divided by 2. Okay, remember, this, when you have the square root of something, of a fraction, you can take the square root of the numerator and the denominator separately. So that's the exact value of cosine of 112.5 degrees by using the half angle formula. Let's look at a little simpler example. Find the exact value of sine of 15 degrees. So we know that sine of 15 degrees is half of 30. So look, sine of 30 over 2. Now we can apply that half angle formula where alpha is equal to 30 degrees. So I'm going to write my formula. So we're going to have equals the square root of 1 minus cosine of 30 degrees over 2. Now we're going to have a positive value here. We're not using negative because in the first quadrant the sine value is positive. So let's go ahead and substitute 1 minus, well, the cosine of 30 degrees is root 3 over 2, and that's all divided by 2. Okay, we're going to multiply by 2 over 2 to the radicand, and we did that in the last example. We're going to do that here. So we simplify, so you get 2 minus root 3, all divided by 4. Okay, and so when you clean that up and you take the square root of a numerator and denominator, you get the square root of 2 minus root 3 all over 2. Okay, so that's our second example. In our last example, we're going to be using tangent. Okay, so we're going to find the exact value of tangent of 75 degrees. So this is the last one I'm going to show you with the double angle formula, and then we're going to verify identity next. So tangent of 75 degrees, that's what we're trying to find the half angle for. We want that exact value. Well, we know that tangent, 75 is half of 150, so we have 150 over 2, so we rewrite that angle. So alpha in this case is 150 degrees, okay? So we're going to take, that's going to equal sine of 150 degrees over 1 plus cosine of 150 degrees. Now I chose to use this formula. Remember, there are 3 formulas we can use for tangent. I just chose this one, okay? So the sine of 150 degrees is 1/2. The cosine of 150 degrees is negative root 3 over 2, okay? So when we simplify, we have 1/2 divided by negative root 3 over 2. You switch and you flip the fraction and multiply. That becomes negative 1 over root 3 because the 2 simplify here. And then finally, you have negative root 3 over 3, and that's when I rationalize that denominator here. Either one of those answers is acceptable. In the last example, we're just verifying that the tangent of alpha over 2, one of our half-angle expressions, is equal to cosecant alpha minus cotangent alpha. Now I like this example because normally with the identities we start on the left. In this case we're going to start on the right side. So notice how I wrote what the right side of the equation is here. All I did here is I rewrote cosecant alpha as 1 over sine alpha. And we know that cotangent is cosine alpha over sine alpha. Now if you notice here they have the same denominator. So you can just subtract straight across them, which I've done here. So you have 1 minus cosine alpha all divided by sine alpha. And by definition that equals tangent of alpha over 2. So, if you guys have any questions or comments, you can go ahead and type them below, or you can email me. We'll see you next time.